the position. And finally, we need to update the boundary objects according to the position and the size of our paddle, which I chose 10 pixels by 50 pixels, 10 pixels wide by 50 pixels tall. Now, since we update the position inside the regions, but we need to update the boundary object for both paddles, we will add that to the very end of the update region, or update method, below all regions. Now, in order to call the keyboard, we need to call the Screen Manager class. And in order to do that, we need to add another using, which is using paddles tutorial.gamescreen. And inside the player controlled region, inside the update, we need to use the input if screen manager .keyboard .up So if we press the up key, we need to set the velocity .y is equal to speed times -1. Else if screen manager .keyboard .down, if we press the down key, we need to set the velocity to a positive y value. And of course, we need to update the position. And at the end of both regions, we need to update the boundary. We need to create a rectangle with the position vectors, the x part of the vector and the y part of the vector, then 10, 50, and we need to convert all those to integers. Int position.y 10, 50. Okay, so that's our boundary. So we do not want the paddles or the ball to fly off the screen, so we do not see it anymore. In order to do that, we need to set a minimum value the paddle can reach and a max value the paddle can reach. This is similar to an invisible wall in most games. If you played games a lot, you will notice some invisible walls. So this is similar to that. So if a paddle reaches the minimum value and still wants to travel up, it will not be able to. The same with the max value. If we press down and it reaches the max value it can go and still wants to move down, it will not. In order to prevent that, we need to set the position is equal to the max value if it's greater than the max value, or position is set to the min value if it's less than the min value. So, since we need to do this for both paddles, we need to add a region above the boundary, but after both other regions, called check position. Okay, so if the position.y is less than a min value, I'm going to choose 10, we need to set the position.y is equal to the min value. Now when you do the same thing for the max value, if position.y is greater than a max value, I chose 540, we need to set position.y is equal to the max value, which is 540. And the reason I chose that is because Well, for one, the reason we hard-coded it is because we do not want to go very, very complicated for this game. And the reason I chose 540 is because 10 is the min value. We want a 10 pixel gap on both parts of the screen. So if we go up, the min value will have a 10 pixel gap from the top of the screen to the paddle. We want that same 10 pixel gap at the bottom. So since the paddle is 50 pixels tall, we need to subtract the max window size, subtracted by 50, and subtracted by the 10 pixel gap, which is 600 minus 60, or 540. And that will give us a 10 pixel gap at the top and bottom sides of the window. And the reason it's 600 minus 60 is because the basic window size is 800 by 600. In the next game, we'll never hard-code anything. But for your first game, it's alright to hard-code a few stuff. Now we need to do a computer-controlled update. Since our player update is finished, we need to now focus on the computer-controlled paddle. This part is a little hard to make the computer difficult, but not impossible. And the reason is because we need to do sort of like artificial intelligence here. You'll notice we have a ball parameter passed, and we'll use that for the computer-controlled update to determine what we need to do. So when the ball is traveling toward the player, which means the ball will have a negative x velocity, the computer paddle will not move. Now we do not want to have the ball class implemented yet, but call ball.velocity anyway with a capital V. So to make things even harder for the computer, we should calculate the y distance between the paddle and the ball. If the distance is smaller than a certain amount, I chose 15, from the center, we will not move. Keep in mind we're not looking for amazing AI for this game, since this is your first. We can come back and visit this AI once we have learned more about game design.